So today we are going to discuss about asymmetric cryptography, and for asymmetric cryptography, RSA algorithm is often used. So we will also discuss about the RSA algorithm, and then we will also discuss about the symmetric and the versus asymmetric key. So asymmetric key encryption is a little bit different from symmetric key encryption, because in asymmetric cryptography we use two different keys for separately for the encryption and the decryption process. And in most of the applications where the asymmetric cryptography is being used, in that case, the sender is going to encrypt the message with the help of recipient public key, and the recipient is going to decrypt by its private key. So what happens in asymmetric cryptography? We use two keys. One key which is known as public key. It is shared publicly to all those who want to be in conversation, and private key is kept with itself. So with the help of this public key and private key cryptography, that is known as asymmetric cryptography, we can encrypt with the help of public key and we can decrypt with the private key. Now the reverse is also possible, that we can encrypt by private key, which can be decrypted by the public key. So the public key and the private key is designed in such a manner that if the message is being encrypted with the help of public key, it will be decrypted by the private key. But if the message is being encrypted with the help of private key, the message can be decrypted with the help of public key. So this is the key matrix, that which key should be known. And this method, this asymmetric cryptography seems to be better than the symmetric cryptography, in which we will be sorting out all the problems which are associated with the symmetric cryptography. That is sharing of the key, which is a difficult part. And then we also number of keys to be handled are very huge in case of symmetric cryptography. So that is also being solved, because in the case of asymmetric cryptography only two keys are used, and if there are 100 users, it means 2 into 100, 200 keys will be there. But in case of symmetric cryptography, if there are 100 users, then the number of keys which will be used are 100 into 100 minus 1 divided by 2, that is n into n minus 1 by 2. So this seems to be better method. Let us discuss. This is the illustration which shows that how asymmetric cryptography is being used, in which the plain text is being encrypted by the receiver's public key, and this ciphertext is sent on the network. And this sender A is being sure that this ciphertext cannot be decrypted by anybody else who is sitting in the network, and this because the ciphertext can be decrypted only by the private key, and private key is known to the receiver only. So one thing is very important, to keep the privacy of the private key, and not it is a confidential for every user. So whatever is the private key, it is kept secret, and it should not be shared with anybody else, but you can share the public key. So if you take an example of asymmetric cryptography, there are many customers of the bank, and every customer will be using bank's public key to encrypt the information, whatever is being sent from the customer to the bank, and bank will be using its private key to decrypt the message. So the RSA algorithm is normally used for applying the asymmetric cryptography, and RSA stands for Revist, Shamir, and the Eldman, because these three are the mathematicians who has invented, who has given this algorithm that is known as RSA algorithm. And this algorithm is most popular algorithm, and it is used for everywhere, whenever a user wants to use the asymmetric encryption. This is based on the prime numbers. And how it works, this is the algorithm for the RSA algorithm, in which you have to select two large prime numbers, and then you have to calculate the value of n, that is p into q, these two large prime numbers. And then we select the public key, try to get the public key E such that it is not a factor of P minus 1 into Q minus 1. And then we select the private key, which is D, such that D into E mod P minus 1 mod Q minus 1 is always equal to 1. So it is the duty of the user to select the public key as well as to select the private key depending upon these conditions, that public key should be such that it should not be a factor of P minus 1 into Q minus 1. And the private key D should be such that D into E mod P minus 1 into Q minus 1, it should be equal to 1. And as far as the encryption is concerned, what we do for encryption process, we use the public key, and for decryption process, we will be using the private key. So for encryption, we are exchanging the plain text into ciphertext, and the plain text, whatever is available, the plain text to the power E mod n is calculated, that becomes the ciphertext. And this ciphertext is sent to the receiving end. And what the receiving end will be doing, it will be decrypting by using Ct to the power D mod n, where Ct is the ciphertext which is being received by the receiver. So Ct to the power D mod n, it will be going to give the plain text. So this is the simple algorithm which is used for the RSA. Now, this is an example in which P is considered to be 7, a prime number, Q is considered to be 17, another prime number, and then n is equal to 7 into 17, that is 119. Then we have to select E, that is the public key, such that it is not a factor of 7 minus 1 into 17 minus 1, that is 6 into 16, that is 96. So the factors of 96 are 2, 2, 2, 2, and 3. So any value which is not a factor of 2, 2, 2, and 3 should be considered, any value. You can consider 5, you can consider 7, it can be done. So here I am considering E is equal to 5. Then we have to select D such that D into E mod P minus 1 mod Q minus 1 is equal to 1. So D into 5, 7 minus 1, D into 5, 96 is equal to 1. So we have to calculate the value of D. So it's, you have to use the trial and error method by considering the value of D. And at a time when you reach 77, you will get 77 into 5. When you take mod 96, it will be 1. So you can select this D as 77. So 77 becomes the private key and 5 becomes the public key. And then ciphertext is being calculated. So ciphertext is how it is calculated, Pt to the power E. Suppose the plain text is 10. So 10 to the power 5 mod 119, that comes around 40. So plain text is 10, but its ciphertext is 40. This 40 is sent to the receiving end. So when the receiver is going to receive this 40, it will be decrypting this 40 by using this method, that is Pt is equal to Ct to the power D mod n. So what it will do, it will 40 to the power 77 mod 19, and it is coming at 10. So it means this algorithm works if we consider P and Q as a large prime number, and then calculate n, then find out E, then D, and then do the encryption and the decryption process. This is again another example in which we have to encrypt a number, a value, that is F. F is the plain text. So F is first converted into its numeral. A stands for 1, so F stands for 6. So 6 to the power 5, it will be getting 41. So 41 is the ciphertext which is sent to the receiving end. And what the receiving end will be doing, it will be using 41 to the power 77 mod 119, and it is getting 6. So 6 is equal to F. So this is how this RSA algorithm works. Now, the important feature of the RSA, or the security feature of the RSA, is that normally the P and Q is selected as a very large prime number. And if P and Q are very large prime number, then and since n is known to everyone, if anybody is able to know n, then it will be difficult for anybody else to find out what is the value of P and Q. So that is why P and Q are selected very large prime numbers, so that if anybody is able to know n, it will not be able to find what is the value of P and what is the value of Q. Now, second important aspect of RSA is that the value of the private key depends upon P, Q, and E. And if anybody is able to know P, Q, and E, it will be very difficult to find out the value of D. So if the P and Q are considered to be a 100-digit number, if n is a 100-digit number, then it will take a lot of time to calculate what is the value of P and Q. So that is why it is being used. But the problem with the asymmetric cryptography is that computational efforts are taken too much. Too much computational efforts are required to calculate the ciphertext and then ciphertext back to the plain text. But it has the advantage that it does not have any kind of sharing of the secret key. It does not have, it has to handle very small amount of the key. But even though asymmetric cryptography is a little bit tougher to use as far as the conversion of the plain text to the ciphertext and the ciphertext back to the plain text are concerned. And research has shown that DS is faster 1,000 times if it is implemented in the hardware, and it is 100 times faster if it is implemented in the software. So besides having many difficulties with the symmetric cryptography, even though the symmetric cryptography is implemented over the RSA, that is asymmetric cryptography. Now let us discuss about the comparative chart of the symmetric versus asymmetric cryptography. The first one is the key used for the encryption and decryption. In symmetric cryptography, we will be using same key, but in asymmetric cryptography, we will be using different key for the encryption and the decryption. As far as the speed is concerned, symmetric cryptography seems to be very fast. Asymmetric cryptography seems to be little bit slower because a lot of computation has to be done for converting plain text into ciphertext and ciphertext back to the plain text. So this speed of doing encryption and decryption is better in case of symmetric cryptography than in case of asymmetric. Size of the resulting encrypted text. Normally जब हम सिमेट्रिक क्रिप्टोग्राफी यूज करते हैं तो जिस साइज का प्लेन टेक्स्ट होता है साइफर टेक्स्ट भी उसी साइज का आता है, लेकिन एसिमेट्रिक क्रिप्टोग्राफी में कोई जरूरी नहीं है कि साइफर टेक्स्ट की साइज प्लेन टेक्स्ट से के बराबर हो. इट मे बी मोर देन द ओरिजिनल टेक्स्ट साइज. Key agreement and the key exchange. Symmetric key, it's a big problem, but in asymmetric key there is no such problem because we don't have to do any kind of sharing of the key. Number of key required as compared to the number of participants. In symmetric cryptography it is too much. In asymmetric cryptography it is less. So in this part it is better. Now as far as the uses of symmetric key and the asymmetric cryptography is concerned, mainly the symmetric cryptography is mainly used for encryption and decryption just to maintain the confidentiality, but it cannot be used for integrity and the non-repudiation checks that is used with the digital signature. But as far as the symmetric cryptography is concerned, it can be used for confidentiality as well as it can be also used for the integrity and the non-repudiation check. If you remember that what is the principles of security, that is confidentiality, availability, authentication, integrity, access control, as well as the non-repudiation. So it is not necessary that symmetric key is going to follow all the principles of the security. Similarly, asymmetric cryptography is also. But if we need only confidentiality, then we will be using symmetric cryptography. But if we need integrity as well as non-repudiation, then in case we can use the asymmetric cryptography. So depending upon the application, we use symmetric cryptography as well as the asymmetric cryptography. So, so it means we have disadvantages and disadvantages of symmetric and the asymmetric cryptography. The people come with the idea, why not to use the best of these two and design an algorithm by which we can use the best of the two cryptography techniques. So the idea is to, the problem with the symmetric cryptography is the sharing of the key, and the disadvantage of the asymmetric cryptography is the computational effort. If the plain text size is large, then it will take more time. So So the idea of using the best of the two is to use the plain text and encrypt this plain text with the help of symmetric key encryption algorithm, with the help of symmetric key, to convert the plain text into a ciphertext. And then what we do, this symmetric key, which we want to share with somebody else, this symmetric key is encrypted with the receiver's public key, so that the symmetric key is encrypted with the receiver's public key by using asymmetric key algorithm. So it means we have done two encryptions. One is plain text is encrypted to the ciphertext by using symmetric key encryption algorithm, and the symmetric key is encrypted with the help of asymmetric key encryption algorithm. So it means we have two encrypted information. One is ciphertext, another is encrypted symmetric key. So why not to put this ciphertext and the encrypted symmetric key into an envelope that is called the digital envelope. And then this digital envelope is sent on the network to the receiving end. And the receiving end is going to receive this digital envelope. And this digital envelope contains what? Ciphertext as well as encrypted symmetric key. So what this receiver will do? It has two information, ciphertext as well as symmetric key. So since it cannot open this ciphertext, it cannot decrypt it, because until unless it is not able to know the symmetric key, it is not able to decrypt the ciphertext back to the plain text. So the first process is to decrypt this encrypted symmetric key by using private key, because this symmetric key is being encrypted by the B's public key, so it can be decrypted by using the private key. So it will do what? It will first use the private key, apply asymmetric key encryption algorithm, and then only it will be able to get the one-time symmetric key. So once it is able to get the one-time symmetric key, it will be using that symmetric key to decrypt the ciphertext back to the plain text. So this is all about